In this video, we're going to work example problems related to line and angle relationships. So just the fundamentals of line and angle relationships. All right. How many endpoints does a line segment have? How many midpoints does a line segment have? So a line segment, we know, is a portion of a line. So a line extends infinitely in both directions, but if you take out a portion of that line, then that's what's called a line segment. And a line segment has two endpoints. So here's A and B, the two endpoints, and it has one and only one midpoint. It's the one unique point that cuts the line segment in half. So if this is the midpoint, then the length of AM, of segment AM, which we just write with, like, this is segment AM, but for the length we just write AM, is equal to the length of MB. Then that's the midpoint. All right, do the points A, B, and C appear to be collinear? No, they do not. Because, so we know that any two distinct points, just 2 points, define a unique line. So if we start with A and C and we draw a line through A and C, okay, that is the only line that passes through both A and C. So if B was collinear with A and C, it would also lie on this line, and it clearly does not. Okay, how many lines can be drawn that contain both points A and B? How many lines can be drawn that contain points A, B, and C? So any 2 points, you can draw, any 2 distinct points, you can draw one line. So there's only one line that contains both points A and B, because those 2 points are 2 different points. But containing A, B, and C, no line, because those points are not collinear. We can draw a line, one unique line containing A and B, one unique line containing A and C, one unique line containing C and B, but not all 3. Consider non-collinear points A, B, and C. If each line must contain 2 of the points, what is the total number of lines that are determined by these points? 3 lines. 3 separate lines. Which of the following measures can an angle have? 23 degrees, 9 degrees, 200 degrees, 110.5 degrees, minus 15 degrees. Well, okay, this is a little confusing. If we take, here's a protractor that goes from 0 to 180 degrees, but you could have a protractor that goes all the way to 360. The answer here is every angle except for minus 15. Now, if you're taking the trigonometry course right now, there's negative angles. There's such a thing as negative 15. But all they're referring to here is it's the same idea of, you can having a negative length. Whenever you get to physics and engineering, there's negative velocities, there's negative lengths. But as far as like an actual fundamental measure, there's no such thing as a negative angle, or like it's in the same sense as there's no such thing as a negative length in actuality. Angles, if there's an opening between 2 straight sides with a common vertex point, that's going to have a positive angle, and in degrees it's going to be something between 0 and 360. Technically, you could have 110.2222345. Now that'd be hard to measure, but you can have that if you have a fine enough protractor and you can zoom in enough. By the fundamental meaning of angle, and if we're talking about degrees, an angle can have measure between 0 and 360. Anything in between 0 and 360, technically that's a measure of an angle. Must 2 different points be collinear? Must 3 or more points be collinear? Can 3 or more points be collinear? Yes, 2 different points are going to be collinear. 100%. They're going to define a unique line. Now, if you like, these 2 points are collinear, so what's the difference between these 2 points? like these 2 points and these 2 points. Well, these 2 points just define a different line than these 2 points. But these 2 points are collinear and these 2 points are collinear. They're just collinear with respect to different lines. Okay, must 3 or more points be collinear? No, not necessarily. But can 3 or more points be collinear? Yes, they can. You can have, so those 2 points are collinear. Let's call that A and B, and this is C, but A and B are collinear with point D. A, B, or A, B, D, and E are collinear, are all collinear. So there's 4 points. Suppose angle ABC and angle DEF have the same measure. Which statements are expressed correctly? All right, so what they're referring to in this question is, so when it comes to equals signs versus the congruent sign, equal is referring to two numbers. Two numbers are equal. So if angle ABC and DEF have the same measure, then the measure of angle ABC is equal to the measure of angle DEF. So that's correct. Now here, what about this? This is incorrect because they're referring to the figures. They're referring to the angles as figures. You don't say two figures are equal. That doesn't make sense. You say they're congruent, not equal. So this is true. And this is false because you can't have two numbers be congruent. Now, so does this mean that if, we're going to learn later what congruent triangles mean or congruent figures. So does that mean if we had two triangles that were congruent, yeah, you could express it like this, but you could also say like the measure of the two triangles are equal as well? No, it doesn't work that way. The angle and the line segment are simple enough figures to where it just works out to where if two angles are congruent, it means their measures are congruent. And if two line segments are congruent, that also means that their lengths are congruent. In a sense, that's their measure. But it's not like if two triangles are congruent, that means like their areas are congruent. It doesn't work that way. So there's no simple way with a triangle to just say that they're equal. I mean, there is a way. I guess that all of the side lengths of the triangles would be of two congruent triangles would be congruent. So you could write each of the corresponding side lengths are equal, but that's a little more complicated than just a simple, you can say that two angles are congruent and the two angle measures are equal, and that's it. Now, remember what congruent means. Congruent is when we're talking about it's the parallel to equal when we're talking about figures. So equal, you're referring to two numbers are the same. Congruent, we're referring to two figures are the same. And the way you think about that is that the two figures could be oriented completely different in 3D space, completely different. But as long as you can reorient one or both of those, spin them, flip them, whatever, you don't change their size and then line them up one on top of the other to where they perfectly align, then they're congruent. That's what congruence means in terms of comparing figures, like line segments, angles, triangles, polygons, things like that. All right, suppose segment AB and segment CD have the same length. Which statements are expressed correctly? So this is, again, it's the special case when it comes to line segments and angles to where if they have you can't really say the measure of a triangle. What are you talking about? Which side length are you talking about? Or it has an area as well, maybe, right? Well, line segments and angles are simple enough to where their measure is, you could only be referring to the length of the line segment. And with an angle, you could only be referring to the measure of the angle. So it works out to where if two line segments have the same length, well, then obviously their lengths are equal, but you can't say their lengths are congruent. This is two numbers. Two numbers aren't congruent. That makes no sense. But then since they have the same length, that also means that they're going to be congruent. Now, and this doesn't make sense. You're saying two figures are equal. And yeah, but they're congruent. So if you had a line segment oriented some random way, I mean, I'll draw 3D space. Let me do that. That'll be a little clearer. So if you had some line segment oriented like that, and then some other line segment oriented completely differently, but they had the same length, then you could they're congruent as well, because you could just reorient it and line them up on top of one another, and it's going to be a perfect match. And same with an angle. So it makes sense that if the measures of a line segment or an angle are equal, they're also congruent. When two lines cross or intersect, they have exactly one point in common. In the drawing, what is the point of intersection? How do the measures of angles 1 and angles 2 compare? So when two lines cross, they meet at one point. That point is point R. The point of intersection is point R. Okay, now how do the measures of angles 1 and angle 2 compare? So if you've taken geometry before, you might be familiar with these types of angles. They're vertical angles, and so we're gonna learn that these are equal, but we haven't learned that yet. So let's just, what they want us to do here is bring in a protractor, okay? And so remember, we can scale this protractor, and actually this is still completely accurate for measuring angles. We couldn't do this with a ruler, like scale the ruler, the size of the ruler. But let's see. We put the vertex here at the center of the protractor, and then let's see, we're about at 55 degrees, okay, and then about 55 degrees again. There you go. So they look to both be equal according to our measurement. Consider the square at the right, RSTV. It has 4 right angles and 4 sides of the same length. How are sides, the segment RS and ST related? How are sides, the segments RS and VT related? So they're referring to these as line segments. You might say, oh, they're equal. No, that's incorrect. They told us that the 4 sides have the same length. So yes, the length of RS and the length of ST are equal, but that's not what the question asked. It's asking, how are these figures related? So we know if 2 line segments have the same length, they're congruent. So segment RS is congruent to segment ST, and segment RS is congruent to segment VT. They're all all of these sides are all congruent to each other. You could actually write that RS is congruent to ST is congruent to VR is congruent to VT. They're all congruent. Okay, use a compass to draw a circle. All right, so we'll use our computer compass here. So there we go. Well, let me actually mark off the center. So there's the center. All right. Now draw a radius, which is, we know a radius is a line segment that connects the center of the circle to a point on the circle. The center is not a point on the circle. This is just a point, a special point in space that's intimately related to the circle, but this is not a point on the circle. All right, so there you go. There's a radius. Measure the length of the radius. Okay, so what we're going to do is we're going to use this ruler here, but these measurements aren't realistic on a computer screen with a ruler, right? I know it depends on the size of your screen, but this is just for demonstration. So, I mean, you know, if I scaled this, a protractor, that actually is realistic, because the scale, a protractor on the computer screen is realistic because the scale of the size of the protractor doesn't matter, but this doesn't make sense. But still, just for demonstration, so let's do this in millimeters. We can get an accurate reading. So, okay, 14 as the 0 point, and then it goes out to, okay, 10, 20, 30, 40, 50, about 56 millimeters. So we'll say AB, the length of AB is 56 millimeters. Okay. Draw other radii and find their lengths. How do the lengths of the radii compare? Well, yeah, based on the definition of a circle, any radius is going to have the same length. That's the definition. All points on the circle are the same length from the center point. So we expect this to be the exact same length. Any radius that we draw would be the exact same length. So okay, 10, 20, 30, 40, 50, about 56. There you go. All right, use a compass to draw a circle of radius 1 inch. So, okay, in that case, we'll bring in the ruler again, but again, we'll bring in the ruler again, but, again, this is not realistic. So, I'll scale it up to make it easier, which doesn't make sense, right? But, okay, the idea is if you were actually doing this on a real piece of paper, you would, with a compass, you would set your compass to lock it in to where you put the center point down like here, and then lock it in to where it's the pen is here, or the pencil is here. So it's set to a radius of 1 inch. And so what we can do here is like that. So let me make sure this is at that on the mark here. Yeah, it's right at the 4, and then it's crossing right through the 5. So the radius is 1 inch. So like that. And then I'll put a point right at well, I probably should have done the center point first. No, we're okay. So I can put a point here, and that should be lined up a little bit lower. Yeah, there you go. So, okay, now draw a chord, which we haven't talked about exactly what a chord is, but that's a line segment that joins 2 points on the circle, but it doesn't go through the center. That would have a different name. That would be a diameter. So a chord would be any line that joins 2 points on the circle, like that. There's a chord. We'll call that A, B, and then draw other chords and measure their lengths. What is the largest possible length of a chord in this circle? Well, we expect that to be going through the diameter, because you could, here's another chord. There's a chord, right? So it's not like the chords are going to have the same length. But we would expect the longest possible chord we can get is going to be going through the center. I guess that is called a chord. It falls under the category of, it's like a subcategory of chord. All diameters are chords, but not all chords are diameters. So like this is a diameter. And so I'm not going to go through the measurement, but if we took out the ruler, I think what they're going for is that we know the radius is 1 inch. So if we measured EF, it's going to be 2 inches. We expect that EF would be 2 inches. And let's go ahead and do it. Why not? So we expect EF to be 2 inches. And it is. But every other chord, any other chord outside of a diameter that we measure is going to be less than 2 inches, is what we would expect. Our intuition tells us that. So there you go. See, it's less than 2 inches. And obviously, so is CD. So the longest chord we can get is a 2-inch chord. All right, the sides of the pair of angles are parallel. So this is parallel to this. This is parallel to this. Are angles 1 and 2 congruent? So they're just asking us to think about if the sides of an angle of two angles are parallel, does that mean that the angles are congruent no matter what? Well, just our intuition, obviously these angles are not congruent. Their measures are not the same, but the sides are parallel. But if we had the case where, so these two sides are parallel in like a certain direction, like this is parallel but in the opposite direction. But if this side was over here then it would look like it looks like angles 3 and 2 are congruent. So it's not enough to say that the two angles are parallel. The two sides of the angles are parallel. It's perhaps if they're parallel, like with the same orientation, then they're congruent. I mean, we don't even need to do a measurement to check if angle 1 is congruent to angle 2. We can tell clearly it's not. Okay, the sides of the pair of angles are parallel, or angles 3 and angles 4 congruent. So they're, well, okay, in this case, they're parallel, not in the same direction, but both are, this is parallel to in the negative sense of this direction, but so is this side. If we come back to, like, these two sides are also kind of opposite. If we come back here, you had these two were opposite, but then these two were the same. So they either both need to be the same parallel or both sides need to be oppositely parallel. And it would seem that they would be congruent, but we don't know for sure. So let's take a measurement and just to see. So we've got, let's see. All right, that's about at 50 degrees, maybe 49 degrees. And here we can do, let's see. There you go, right about at 49 degrees. So perhaps that is, it looks like these two angles are congruent. Our measurements would suggest that they are. So, all right, the sides of the pair of angles are perpendicular. Are angles 5 and angle 6 congruent? Okay, so we've got this angle. This is a 90-degree angle. This is a 90-degree angle. So are angles 5 and 6 congruent? We could take a measurement, but perhaps they want us to do this more analytically. So if we call this angle 4, then we know that, so angle, the measure of, I mean, I'm not writing the notation correct here, but I'll do this. So measure of angle 4 plus measure of angle 5 is equal to 90 degrees. And the measure of angle 6 plus the measure of angle 4 is equal to 90 degrees. Okay, that makes sense. That's what they're saying here. Now these two are equal, so we can set these equations equal to each other. Now if we subtract the measure of angle 4 from both sides, then we get, so yeah, angles 5 and angle 6 are congruent. Because their measures are equal. So measure of angle 5 is equal to measure of angle 6, and then angle 5 is congruent to angle 6. All right, the sides of the pair of angles are perpendicular. Are angle 7 and angle 8 congruent? So let's see. This angle is perpendicular. It doesn't look like visually that these angles are going to be, 7 and 8 are going to be congruent. And so, but what would a relation between them be? Well, okay, a full rotation is 100 or is 360, and these two pieces are 90, so that means angle 7, the measure of angle 7 plus the measure of angle 8 is going to be 180, but that doesn't necessarily mean that they are the same measure. You could have, one could be 60, the other could be 120. You know, I think visually we can see that they're not going to be congruent, and that's the only thing we need to answer here. That's the only question we're trying to answer. So that's about at 120, yeah. And so if that's the case, the other one's going to be at around 60. So put the vertex at the center of the protractor, and yeah, right around 60. So no, they're not congruent. The answer here is no. But they do add to 180. A trapezoid is a four-sided figure that contains one pair of parallel sides. Which sides of the trapezoid MNPQ appear to be parallel? Well, here, MN, line, the way we write this is line segment MN looks to be parallel to segment QP. You could see. With parallel, the idea is if you looked at consider the full line MN extending to the right and left in all directions, and QP extending to the right and left and infinitely, then those lines would never intersect, no matter how far down the line you went. Then they're parallel, and that looks to be the case. But not NP and MQ, because if you extended, and going this direction, if you extended them, they would never intersect. But you can go in either direction. As long as they intersect in some direction, then they're not parallel, and they would intersect here. So no. But MN and if you went in QP, if you went in either direction infinitely, those lines would never touch. In the rectangle shown, what is true of the lengths of each pair of opposite sides? So they're telling us that it's a rectangle, but we haven't officially defined what a rectangle is. So we can measure this and see that. So, okay, that side's about 13 millimeters, 12.5 millimeters, and this is going to be the exact same length on the opposite side. And then if we measured this side, we're at about 19 millimeters, and this could be the exact same length. So RS is congruent to VT, and ST is congruent to RV. That's what looks to be true. A line segment is bisected if its two parts have the same length. Which line segment, A, B, or CD, is bisected at point X? So AB is bisected. It's divided into two equal parts, but CD is not. An angle is bisected in the same way if its two parts have the same measure. Use three letters to name the angle that is bisected. So what angle is bisected here? So we can see that angle ABD is bisected. ABD, this angle, is bisected. It's divided into two angles of angle ABD is 20 degrees. The measure of it is 20 degrees. It's bisected, so it's divided into two 10-degree angles. Find AC, length AC, if AB is equal to 9 and BC is equal to 13. So, okay, we know that the length of AB plus the length of BC is going to be the length of AC. We can see that. Length of AB plus length of BC is going to be equal to the length of AC. So the length of AC is 9 plus 13, which is 22. All right. What about the length of AB if AC is 25 and BC is 11? Well, we can use this relation here, solve for AB, subtract the length of BC from both sides. And so AC, well, this is 22. AC is 25. BC is 11. So that's 14. All right, find X if AB is equal to X and BC is equal to X plus 3 and AC is equal to 21, then what must X be? Well, the relation here we know, again, is the length of AB plus the length of BC is equal to the length of AC. So, okay, let's just plug these in. If AB is equal to X and BC is equal to X plus 3 and AC is equal to 21, now let's just solve this. So X plus 3 is equal to 21. 2X plus 3 is equal to 21. 2X is equal to 21 minus 3 is 18. Divide both sides by 2. X is equal to 9. Okay, find an expression for AC, the length of AC, if AB is equal to X and BC is equal to Y. So once again, we know that the length of AB plus the length of BC is equal to the length of AC. Let's just substitute these, what they give us here. AB is equal to X. BC is equal to Y. AC is it just is what it is. So it's x plus y. The length of AC is equal to x plus y. Is that what they wanted? Well, that's not the, no, not line segment AC. The length of AC is equal to x plus y. Yeah, that's it. Angle ABC is a straight angle. Using your protractor, you can show that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees, which makes sense. A straight angle is going to be 180 degrees. It's a half of a full rotation. Find the measure of angle 1 if the measure of angle 2 is 56 degrees. So we're going to take this formula. They give us the measure of angle 2. So the measure of angle 1 plus the measure of angle 2 is 56 degrees is equal to 180 degrees. So the measure of angle 1 is 180 minus 56. Subtracting 56 from both sides. So 124 degrees. Find the measure of angle ABC if the measure of angle 1 is 32 and the measure of angle 2 is 39. So if ABC, we can see that the measure of ABC is the measure of angle 2 plus the measure of angle 1. So the measure, that's what we can clearly see. The measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2, which they give us. Measure of angle 1 is 32 degrees. The measure of angle 2 is 39 degrees. So 39 plus 32 is 71 degrees. Okay, find the measure of angle 1 if the measure of angle ABC is 68 degrees and the measure of angle 1 is equal to the measure of angle 2. Okay, so again, I mean, I'll write this up here as like the master formula. So the measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2. So if the measure of angle ABC is 68 degrees and then angle 1 is equal to angle 2, then we can just set angle 2 equal to angle 1 and we get measure of angle 1 plus measure of angle 1. So yeah, I don't want to go too fast. So we can set the measure of angle 2 equal to the measure of angle 1 in that formula. So we've got this. So we have 68 degrees is equal to 2 measure of angle 1. Divide both sides by 2. You've got measure of angle 1 is equal to, so 68 divided by 2 is 34. Find x if the measure of angle 1 is equal to x, the measure of angle 2 is equal to 2x plus 3, and the measure of angle ABC is equal to 72 degrees. Let's just use this relation here. Angle 1 is x, angle 2 is 2x plus 3, and ABC is 72. So now let's just solve for x. 3x plus 3 is equal to 72. Subtract 3 from both sides. You get 69, so divide both sides by 3. That's going to be 33, I believe. Or no, not 33. 23, I think. Yeah, x is 23. That would be degrees. Find an expression for the measure of angle ABC if the measure of angle 1 is equal to x and measure of angle 2 is equal to y. So yeah, we're just going to get measure of angle ABC is equal to x plus y. That's it. You just substitute measure of angle 1 for x and measure of angle 2 for y. A compass was used to mark off 3 congruent segments, AB, BC, and CD. Thus, segment AD has been trisected at points B and C. Because we know that because if AB is congruent to BC is congruent to CD, then AD as a whole is 3 equal parts, which means it's trisected. If AD is equal to 32.7, then how long is segment AB? Well, okay, we know that we're looking for AB, length of AB, but we know they just told us that that's equal to BC and that's equal to CD, those lengths. But we know that when we add up these three lengths, well, let's call this x. We're trying to solve for x. If we add up, so if we call this x, then we know that x plus x plus x is equal to AD. It just told us that AD is 32.7. So 3x is equal to 32.7. So, okay. 10.9. That's the length of AB, BC, and CD. Use your compass and straight edge to bisect EF. So what they want us to do here is so let's see, we've got 10, 20, 30, 40, 45-ish. So we want to go about 22 and a half, 10, 20, but we're going to use the compass. The idea is you would set the compass equal to its radius equal to that length. So 22 and a half. So one about right there. And now we're going to draw a little arc there. And there you go. That's the bisection point. And the idea is you could take the compass, and so if we come back to the compass, so we've got the radius set, and we could go anywhere in that we want, and put a start point. So here's a start point, here's a start point, whatever, and get the compass with that radius fixed, put it at the center point, and there you go. Now that if we connect, we can connect this center to any point here. It doesn't matter, and that would be congruent to that line segment. Any point we want. Connect this point to any point on that segment, and that's same length as E to the midpoint. Right, so there's a congruent line segment to E, we'll call that EM. That's congruent. That's congruent. That's congruent. In the figure, the measure of angle 1 is equal to x, and the measure of angle 2 is equal to y. If x minus y is equal to 24 degrees, find x and y. So the key here is that they tell us that x minus y is equal to 24, and that's corresponding to the measure of angle 1 and angle 2. So how can we solve for x and y? Well, we need another relation between x and y, and what we know is that angle ABC, that's a straight angle. So we know that x plus y is going to be equal to 180. So now we've got two equations and two unknowns. Let's add these two equations. So you have 2x minus y plus y goes to 0 is equal to 204. So now divide both sides by 2. That's going to be 102. So x is 102. That makes sense. It's greater than 90. And now 102 minus y, we can just substitute x into either one of the equations, is equal to 24. So y plus 24 is equal to 102. Y is equal to 102 minus 24. Y is equal to 78. There you go.